Huyen, do you want to share your screen? Once again, welcome. A few housekeeping notes before we start. Please have your camera off and mics muted. There will be a Q&A session after the talk. Feel free to post questions in the chat box. Also, this webinar will be recorded and posted online. Today, we are very fortunate to have with us guest speakers, Professor Terry Lyons, Dr. Lucas Bruch, and the authors of an introduction to machine learning in quantitative finance, Dr. Hao Ni, Dr. Xin Dong, Dr. Jinsung Zhang, and Mr. Guanxi Yu. They will be sharing the insights into the future of machine learning in quantitative finance. A few things about our guest speakers. Professor Terry Lyons is the Wallis Professor of Mathematics. He is currently PI of the DATASIG program. He was a founding member and then director of the Oxford Mann Institute of Quantitative Finance. And Dr. Lucas Bruch is a reader, associate professor at the School of Mathematics, University of Edinburgh. He is also a scientific director of the Finance and Economics program at the Alan Turing Institute, London, where he is also a research fellow. So before we start the presentation, maybe the authors would like to give a short introduction for themselves.
Hello everyone, I'm Hao Ni and I'm an associate professor in mathematics at University College London, and I'm also a Turing Fellow at the Alan Turing Institute.
Hello, my name is Xin Dong. I'm currently working as a quantitative researcher at the Citadel Securities based in London since 2018. And previously I worked in Morgan Stanley for 3 years. Yeah.
Hello everyone, my name is Jinsung Zhang. Currently I'm an algorithm engineer at Huatai Securities in China. Prior to this, I was a quantitative manager, risk manager at Talanx AG in Germany. Now my current interest parts are the quantitative investment and asset allocation, especially using machine learning techniques and big data.
Hello everyone, I'm Guanxi Yu. Now I'm a quantitative analyst at SWS Research in China. My research includes financial data analysis, quantitative modeling, and equity strategy.
Thank you very much. And now let me hand this over to Hao and Guanxi to kick things off.
I'll share my slide. Thank you everyone for coming. It's my great pleasure to have all of you here to join this special event and celebrate the launch of our book. In the following, Guanxi and I will give a presentation on our book and related topics in machine learning and quantitative finance. So to start with, let me give you a brief introduction about my research background and talk more about the story of writing this book. In the slides, you can see two quite different pictures. The left one is the cover of my PhD thesis with a background, which is a typical page of my thesis, while the right figure is a collection of the images used in my current working papers. Based on the colorfulness of those two figures, you can probably tell how different my current research and my PhD study could be. I did my PhD in mathematics at University of Oxford, and I'm honored to have my PhD supervisor, Professor Terry Lyons, to be here as a guest speaker. And my PhD study was quite theoretical, and it doesn't include much about the numericals or the applications. In contrast, I'm now actively working on a number of the applications joined with the domain experts. The application ranges from predicting the activity score of the molecule in biology, recognizing the action class from the skeleton-based video data in computer vision, and forecasting the volatility of FX in finance. Indeed, my main research interest has switched to develop the generic and efficient algorithm to analyze the multimodal data. As a transition from the mathematical research to the multidisciplinary machine learning related research has started since the end of my PhD study in 2012. And this transition is not straightforward. It took me a while to get used to the style of the other disciplines, statistics and machine learning, as well as the applications. Over the years, I digested those learning materials and gradually summarized it into within my own framework. On the other hand, I have many friends who have similar educational background as me, and they work in financial industry. I heard from them that they were very interested in machine learning, but they were quite busy and they didn't have much time to learn it. And also they were not sure what the best way to start it. Therefore, I came up with the idea of sharing my learning experience with them, so that to help them to reduce some learning curve to start the ML research. With my course Xingdong's encouragement, I organized a series of the meetup events to teach financial practitioners about the basic ML algorithm and the application in finance in 2018. I received quite valuable and positive feedback, and one participant mentioned that the event shouldn't be free and he'd like to pay for joining such an event. And after the meetup events, my father suggested me to write a book based on the teaching material of that activities, so as to disseminate it to a wider audience. With his help, I managed to sign the contract of the book, of the Chinese version and English version, with the Tsinghua University Press and the World Scientific Press, respectively. This is the start of this book project. I invited my 3 co-authors to join the project, and we formed a team with the complementary skill set. Xing wrote the 2 chapters on the unsupervised learning. Jing Song helped me with the coding and as well as the writing of the reinforcement learning and the case study. Guanxi actually translated the whole book in English to the Chinese version. I owe my deepest debt to my co-authors. They are full-time employees working in financial industry, and they, however, they contributed to this book significantly. Without their contribution, it would be mission impossible to finish the book of Chinese version and the English version within 2 years' time. Apart from my co-authors, I have a long list of the people I want to say thank you. First of all, I want to thank the editors and the marketing staff from the World Scientific Publishing and as well as the Tsinghua University Press. Besides, I want to thank my friends who helped me with the organization of the meetup events and providing the venue to host those events. Moreover, I'm so grateful for many people who helped me with the proofreading and provided the valuable suggestion on the book marketing. Furthermore, I'm grateful to my PhD student who helped me with some of the numerical results in the book. The last but not the least, I want to say thank you to my dear family who gave me continuous trust and support. That's the story of the writing this book. In the second part of this presentation, I'd like to give a very brief high-level overview of the machine learning. Now I will hand it over to Guanxi, and he will continue to talk more about the application of ML in finance and in particular in Chinese market. The world is undergoing the data exposure, and we are indeed at the era of the big data, which refers to the data with 3 V characteristics, that is volume, velocity, and variety. Volume defines the the large amount of the data which can be produced by the business process, individual activities, and the sensors. A modern telescope can generate terabytes of data per observation, and the simulations required to mimic the observable universe can push the computer to their limit. Velocity means the high speed of the arrival of the data streams. High frequency trading could be a very good example. The high frequency financial data could arrive every milliseconds. Moreover, data come in all forms, from the structured numerical data in the traditional database to unstructured, the image, text, video, and so on. So those 3 V characteristics has imposed significant challenges to the traditional statistical method. However, in the meanwhile, it provides a lot of opportunities, as we know that there are useful information hidden in this big data. Therefore, it's essential to develop the more advanced technology to extract the useful information from the big data and make better usage for the prediction and decisions. Machine learning is an ideal candidate to exploit such opportunities. Machine learning algorithms operate by building the models based on an exemplar training set of the observational data, and also use it to make prediction and decision instead of following the static rule. It's data driven and it runs at the computer level. Moreover, it's well suited to the complexity of handling the data of the variable types and also the huge amount of the data. Unlike the traditional statistical data, usually the machine learning algorithm thrives on growing the data sets. A machine learning algorithm can be broadly divided in three major types. That is supervised learning, unsupervised learning, and reinforcement learning. Supervised learning aims to learn the functional relationship between the input and the output, while the unsupervised learning is used to discover the hidden structure from the unlabeled data. In contrast to them, the main objective of reinforcement learning is to learn how to interact with the environment and discover the error and the reward. So in the past year, machine learning has achieved a great success in many fields. In particular, deep neural network has been applied to various fields, ranging from the computer vision, natural language processing, and biology. So recently, AlphaFold is developed to predict the molecule structure. Moreover, it's well known that AlphaGo defeated the world-class champion Lizzie Doe in the Go games in 2016, which uses the technology of the deep reinforcement learning. So I think I'd like to stop here and hand it over to Guanxi. Hello, Guanxi, could you unmute yourself?
Yeah, sure. Well, hi everyone, I'm Guanxi, and thank for the invitation of Dr. Hao and the World Scientific Prize organization of this fantastic event. Now I'm working as a quantitative analyst of SWS research in Shanghai, and it is a great honor here to introduce you with this book and share some of my experience with machine learning. I will also share some latest developments and applications of machine learning in Chinese financial markets. I would like to start with my experience with machine learning. The first advanced machine learning algorithm I learned is Gaussian process, and in my postgraduate studies, I combined the Gaussian process with reshaping theory to detect some features of time series and then make some predictions. After graduation, I joined a securities company in China, is WS Research. I worked as a quantitative analyst, and my main job is trying to apply machine learning algorithms into finance. Well, I think since I went through the difficulties of learning algorithms and finally become a professional who live on it, I found writing this book is a fantastic opportunity to share my experience with those who are interested in this field. This book has a clear structure that could guide readers to explore the machine learning world. Today, we have made some progress in financial applications, but we also have many challenges when facing financial data, which result in some limitations of applying machine learning into finance. Well, the first is low signal to noise ratio of financial data. It makes more difficult to extract real signal using machine learning methods. So feature engineering with domain knowledge is very important before you build any models. The second challenge is heterogeneity. That is, financial data structure is usually unstable. For example, once an important policy was announced, the mapping of two policy-related financial time series may problem change. Last but not least, low availability of financial data makes apply machine learning method less possible. One of most important features of machine learning is data-driven. So the performance of algorithm is highly related to the data in terms of quantity and quality. Sometimes we don't have large number of samples. For example, most of economic data is monthly or quarterly updated. And on the other hand, sometimes we don't have structured data. For example, the news data, the research report, and some real-time comments. Next, I would like to talk about the machine learning applications in industry, mainly in Chinese financial markets. Despite all these challenges of financial data, we also have made some programs in quantitative investment. At first, fintech is a hot topic today. It is a good combination of technology and business knowledge. Some large mutual funds or fintech companies, well, they developed their own AI advisors for the personal customers. It is kind of like recommended systems. The personalized marketing strategies and investment advice can improve the efficiency of marketing. And some data companies also use the knowledge graph of industrial chain. Once a news or a policy released, they can quickly locate the related stocks. Well, secondly, as for the factor investment, it is another application scenario of machine learning. We can use machine learning algorithms to dig new factors. For example, we can use the genetic programming algorithm. In addition, it is always attractive to predict stock returns. For example, we can use some advanced models. For example, it's neural networks or ensemble models to build the map of factors and returns. And alternative data is also important. For example, the news data, and we can use some techniques, for example, the ALP to find alternative factors. And because these factors are not very commonly used, so now they are usually effective. And we also develop some marketing time strategies. And it is mainly about high frequency data. We also have a practical example in our book. Well, I think that's all my speak today. Thank you very much for your time.
Thank you both. And now I'd like to invite Professor Terry Lyons, Dr. Lucas.
Sorry, we actually haven't finished the presentation. Sorry. Yes, thanks, Guanxi, and I will continue to give a brief introduction about our book. So this book has started with an overview of the ML and financial application, and then we covered the three above mentioned types of machine learning algorithm. That is supervised learning, unsupervised learning, reinforcement learning, and it ended with a case study, one popular Kaggle competition on home credit for risk. And I will talk about some highlights of the supervised learning section to demonstrate the unique features of this book. So as you know that the supervised learning is used to infer the function f, which maps the input x to the output y based on the labeled input-output pairs. In the book, we summarize the framework of the supervised learning, which are composed with data, model, loss function, optimization, prediction, and evaluation. And we introduce the models from the simplest linear regression model to the more sophisticated nonlinear model, such as tree model and a neural network within the framework. It enables the reader to learn other new supervised learning algorithms in a more systematic way using this framework. Moreover, we added more mathematical intuition behind the algorithms. For example, we explain how to generalize the linear model to the nonlinear model using the basis expansion. Neural network is one of the most popular learning algorithm, and the neural network has great power because it could be applied to different applications. So some people who treat the neural network as black box might think that it's like the magic to be used to solve different problems. However, that is just because that this kind of the neural network have universal models. That means no matter what the ground truth this functional relationship between input and output is, we can always find a certain neural network to approximate this function arbitrarily well. And in the book, we explain from the point of the functional approximation theory, the shallow neural network is a pretty intuitive candidate to approximate the continuous function. Just like the piecewise constant function, but with better differentiability. And those discussions can be summarized in the universal, in the elegant and a precise universal approximation theory, which was actually studied in 1989. However, in practice, if we want to apply the neural network to the concrete applications, the universality is never enough. And we gave more discussion about why, what is the most essential thing when we apply those learning algorithms to the practical data. Moreover, in the book, we dive into different kinds of the neural network, from the shallow neural network to the deep neural network, as well as the convolutional neural network and the recurrent neural network. For the recurrent neural network, we provide you with an example of a prediction of the mid-price movement on the high-frequency data set. In this task, we ask ourselves, can we use the limit order book data to forecast the next mid-price movement given the involvement of the limit order book evolution over certain look-back window. We describe how to solve this problem step by step and provide a Python notebook to showcase how to implement it. The reader can download and run this Python notebook using Google Colab Tree without installing any Python environment. By just modifying the input and output, probably the user can use it for other financial application conveniently. To sum up, this book has a balance between systematic and rigorous theoretical foundation and the ample examples of financial application. We hope that it can help the readers to build the solid knowledge base of the machine learning algorithm, but also equip them with the hands-on experience of applying the algorithm to the empirical data set. And for each algorithm, we provide the Python implementation. And you can find all the supplementary Python codes of this book in the Google Colab Tree, whose link could be found at the link in the slides. So finally, I want to say that we really hope that this book can help the beginners in ML and quantitative finance to get quicker start and help them to enjoy their new journey of applying the machine learning to their exciting financial problems. So that's all I want to present today. Thank you.
Thank you, Hao. And now I'd like to invite Professor Terry Lyons, Dr. Lucas Bruch, Dr. Xin Dong, Dr. Jinsung Zhen to join Dr. Hao Ni for the panel discussion.
Yeah. I will chair the panel discussion and thank Terry, Lucas, Xin, and Jinsung to join this panel discussion. So the first question to all the panel member is as follows. In your opinion, how does machine learning impact the landscape of quantitative finance or more broadly, financial sector? So Terry, would you like to kick it off?
Yeah, but I have a hearing problem, which is nothing to do. I didn't exactly get the words of your question.
How does the machine learning impact the landscape of quantitative finance? And
Okay, fine.
yeah.
Fine. Let me have a few notes here. Okay, so first of all, thank you very much for inviting me on to this panel discussion, and congratulations on getting to produce this book, which is a great achievement, and my warmest thoughts for you about that. Okay, so finance is partly about instincts and things, but actually most of it, thank goodness, is about data, and the data in finance is complicated and on hugely different scales. It goes from ticks to order books to macroscopic features of economies. And whatever people say, there might be plenty of data, but it's not actually plentiful in the sense of lots of independent samples. It's very high dimensional data, and that actually is a challenge, not an opportunity. And there are lots of things to think about in that space, and machine learning is very much about recognizing complex patterns that aren't necessarily that difficult, easy to articulate, and I think it plays a huge role in that. So you want to understand, but I think it needs mathematics to do that too, and so this book is very well positioned. I think it needs to understand the restrictions that are imposed on data by the markets. It needs very much to be able to simulate. There's a lot of value in simulating markets, and the data science can help enormously in teaching us how to simulate markets. You might think that simulating is different to pricing, but it's not really. What you want to be able to do is one layer beyond simulating. You'd like to be able to simulate the future given the past. It is hopeless to predict the price tomorrow because it's random. What is much more useful is to predict the law of the process, the randomness. In other words, to simulate the future given the present. And I think we're seeing with GAN and we're seeing with our own techniques, lots of new methodologies that can be used to simulate. But it's important to use data, not just theory. I mean, the LSE in London is quite a different market and will behave very differently to the Shanghai Stock Exchange. They have different rules and different fine structure. It's also very important to use data because of this fine structure. It's almost impossible to systematically capture all the differences in every one of these high dimensional situations. High dimensional things are not things that human beings are good at simulating, understanding directly. I don't know if that answers your question, but I think for sure, our ability to simulate, I would pick out as one of the most significant features moving forwards in the use of data science to better capture the behavior of markets and quantitative finance. I would say while we're at it though, that just the increased numeracy of it, I mean, your book mentions, has Python, it has websites with Python. I think just everybody becoming so much more numerate is also quite a helpful thing. Okay, that's from me for now.
Yeah, thank you, Terry. Lucas, would you like to share your thoughts on it?
Sure. First of all, thank you for inviting me to this panel discussion, and congratulations to all of you for the book. Very much needed. The whole machine learning landscape is not easy to navigate. It's plenty of methods and ideas, and especially to the newcomers, this is very challenging to identify what methods to use for what data set. So well done. I think you perfectly captured the balance between being rigorous on one hand and on the other hand, helping the readers with useful examples coming from finance. So I agree with everything what Terry just said, but I'd like to also add that machine learning and data science is profoundly changing financial industry. Of course, there are parts of financial industry such as derivatives trading or hedge funds, investment funds that were using advanced statistical tools for quite some time, and they're very good in that. And where what machine learning brings now is provides a new perspectives and allows potentially to revisit some of the old ideas and enhance them, but not necessarily replace them. But there's another part where there's a big chunk of financial industry. For example, retail finance, where you've mentioned that you have example action credit scoring. And that's a part of finance industry that historically has been using relatively simple tools, linear regression classification, and all of a sudden, there's a huge appetite and realization there's a ton of various data sets that can be used to process. And so big chunks of the finance industry that weren't exposed to this technical, complicated data science tools all of a sudden are experimenting. And as it has been identified by Financial Conduct Authority and Bank of England in the UK and World Economics Forum, they run the surveys globally to understand how AI is changing the financial services industry. And the conclusion is that everywhere, at every corner, there is a lot of experimentations, but also there are challenges. There are new challenges that arise related to some of the ethics, explainability of some of those methods, fairness issues, and that kind of stuff. So that's a whole plethora of opportunities, but also new challenges ahead of us. Thank you.
Yeah, thank you very much, Lucas. Xin, would you like to follow up? Provide the perspective from the practitioner's view.
Yeah, sure. I think Lucas and Terry have given a very good view on about this question. So as a practitioner, my experience is only covers one specific area in finance. So instead of maybe telling the overall kind of impact, I'd like to share a little bit with you about my observations and my my understanding. So I think there are three things that the machine learning has brought, quantitative finance, or the area I have been working on, which is market making in market making. So the first one is I think it helps to, so if you think eventually what is important, what is actually important in this industry, as a practitioner, I think basically you are solving problems, and you try to use the data or more advanced technique to understand the problem better first. So I think so. My first point is it helps people understand the industry better, and I think the domain knowledge is very important, in machine learning, no matter which area you work in. So I think it's an iterative process that you master better the technique, or the machine learning methodology, and you gain better domain knowledge, and then the domain knowledge, better understanding of domain knowledge can help you to find a better way to use like the machine learning method to solve the problem. So I think that's the first thing. Second thing is I think it improves like the efficiency and accuracy, like one of the decision-making process. This is like a no doubt. I'll combine with the third point. So the third point is I think it helps to automate a lot of like processes. I think it is quite valuable because it gives people like the freedom to focus on more interesting and more and contribute with like more insight instead of like some manual work like you have to repeat like a daily or in certain like processes. So I think the second point, the third automated process improve like the decision making. I think they're very important, and I think I probably can give some examples like later, but overall, I think like it brings like long-term kind of impact in this industry. Yeah, that's my answer.
Thanks, Xin. Jin-Song, would you like to share your opinion on this question?
Okay. Okay. Yeah, thank you for the invitation. And now I would like to introduce. I would like to say my opinion on it. I think the application of machine learning has been transforming the financial industry. It affects many sectors. For instance, the insurance, banking, and also the investment and asset management. For banking, from my opinion, it could give better customer service. For instance, using the natural language programming, the NLP, and then you can use, for instance, a robot advisor, and then you can communicate with it and solve most of the standard problems. And also it can increase the efficiency of the loan process, because you can just apply the loan on the online and do it. And also can just detect the fraud. So the fraud detection for the banking using some machine learning techniques. This is from the bank for the banking. And for insurance, by now, so many many insurance, they also use they create some big data center, and they use large data, big data to introducing their pricing processes. For instance, the car insurance, they will use lots of information from the car driver, and they collect them, and then can do better pricing for the insurance contracts. And for asset management and investment, now people will use some machine learning techniques to generate some investment signals, to do some automatic trading, and also like robot AI advisors for construct some particular portfolios for particular customers. So from my opinion, the machine learning can take many new things to all the financial industries, to insurance, banking, and asset management, etc. Yeah, that's all.
Thank you very much, Jin-Song, for sharing his view on that. So my next question for the panel discussion, also the last one, is about the future of ML in finance. So how do you foresee the future and the trends of ML in quantitative finance or fintech in the next 20 years? So Terry, would you like to start? Terry, you should unmute yourself. Terry, you are muted.
Yeah, sorry, I'm not anymore. I was saying that it'd be much better to start with somebody else, and then I could say I agree with them all. The future of quantitative finance, well, it's going to carry on because people need money, and they need, I mean, finance is actually about an important function in society, really, and so it's definitely going to carry on. I think the points that people have been making in the previous discussion are quite relevant, though. I think we will take a much more personalized view of people's finances and of corporate finances. So we will use methods to detect fraud. We will use methods to understand anomalies in markets. But we'll also use it to advise people, to let people understand for their own personal finances, the future. So in a sense, that is not such a different problem to the problem in the hospital, where you you track the evolution of somebody in a hospital up to the current time, and you would like to understand whether they are likely to get better or get sepsis in the near future. This is the sort of thing we do now, but it's not so different to look at somebody's life up to now, that they've been married, they have 2 children and so on, and to understand how their future is likely to evolve and merge with, but that's a tricky thing to do, the evolving financial world, to think how they would invest their money, what they would do with their resources, and to offer better, I hesitate to use the word advice because that's always complicated, but advice. So I think we'll see significant changes. I think the more ground-changing ones will be about how people interact with finance. That's it.
Yep. Thank you. Xing, would you like to go next?
Sure. I think it's a tough question. The next 20 years. Yeah. I think maybe not for 20 years, but I think the what is like a trending now at the moment. Probably also what I saw like since years ago. I can't predict say the exact a machine learning method because it keeps evolving. But I think on the application side, I can see machine learning will help more and more in the decision making process, and also I think it will naturally keep the whole industry moving towards the systematic and automated this direction. And how long it will take, I won't say eventually everyone will be replaced by machine learning, but I think it definitely will free some people's idea and make us more open-minded with more information extracted from the data using machine learning a method, and also as I think Terry also mentioned, I agree that it can help to systematically and deal with a problem, and also provide a scalable solutions. Yeah.
Thank you very much, Xing. So Lucas, what do you think about this question?
Yeah, it's a good question. And 20 years is a long time horizon. So there are many exciting things. So I see finance industry as an ideal playground for machine learning, data science, and AI. In that this is the industry that is highly regulated. There is a governance around data and models that is already in place to some degree. So from that perspective, they have a bit of an advantage over some other industries where people are experimenting with technology. There's lots of data, there are incentives. So that's an interesting space from that perspective. There is many things that will be happening at the moment. We live in an AI hype. Everyone is excited about this. Everyone is trying to throw complicated models at the data because that's fashionable. But I think what we're going to see over the next, maybe not 20, but 5 years is we will be learning what are real contributions, what are opportunities for some of those more data-driven models, and also we'll learn about some of the limitations. I think that some of the things that we currently use actually are very good. A good example is the type of models you are working in, Terry, about signatures, that they extrapolate nicely between a more classical modeling framework with more modern data-driven techniques, and we will see more and more of those hybrid methods. The other big changes on the horizon, there is a lot of effort that is going into something called, goes under the name decentralized finance, idea about building decentralized financial system. It starts with a blockchain, but the idea is much bigger. And that's the interaction of technology, data science tools, and also other parts. I think this is a very, very exciting space, including automating markets, automating market making, and plenty of exciting applications. So I think it will be exciting time. I think we'll learn more, and once the hype of AI will settle down, the dust will settle down a little bit. We will see some very exciting challenges. And also, you've mentioned reinforcement learning and DeepMind and big successes, and all of that is around essentially transiting from what I call offline learning to online learning. The plenty of problems out there in finance that can be recasted as reinforcement learning. But of course, the consequences of learning in online, trying with various policies to learn, is often too costly. So we will need to do a lot of thinking how to learn from the data that we have, and that touches the point what Terry mentioned at the very beginning. The building of effective simulators, extrapolating currently available data, and using that to minimize the risk as we're trying to optimize into the future. So yeah, I think it's going to be a very exciting time, the next 20 years in finance.
Yeah. Yes, thank you, Lucas. Jingzong, would you like to share your thoughts on that?
Yes. I think 20 years is long. And I think from my point of view, currently the data quality is still poor. So, and the data is from in finance industry, in some aspects, they are still not that big. So I think in the next few years, the financial industry, they will try to develop some kinds of data center and improve the data quality. So I think one aspect will be developing the data, so to create some large data database, etc. This is one point, and another point, I think in the next few years, people will just think more about the model validation. So right now, the machine learning is just will be used and is not regularized. So people will not check, okay, it's a black box in it, so just use it. I think in the next few years, if we should use it better, then it will, in some fields, they will just try to explore the black box. And of course, as the other, as like Xin said, I think it's also, it will be used to for instance, to lower the cost and make the financial process more faster and more effective. I think this is also one aspect that definitely will be will be used. Yeah.
Thank you very much, Jin-Song. I think now we finish the panel discussion and move on to the Q&A session.
Thank you very much. Now we can move to the Q&A session. There is already one question in the chat box. Terry already replied to it, but perhaps you have a different opinion. As ML grows, will it not start also producing the data it subsequently learns from, and so set up feedback loops, for example, flash crash on a regular basis?
Maybe I can answer that questions. I actually agree with what Terry said. I think it's almost inevitable. Also, even the current high frequency trading, many trades are actually algorithm. It's based on the algorithms and automated executed. And definitely it will affect the market. But I think more importantly is how to design the algorithm with better. How can we define the algorithm such that it can robust handle those extreme market situation and don't result it in the disastrous situation. We should take those into account of the designing the algorithm. But this feedback mechanism between the algorithm and the market is somehow, I feel this is something normal. So maybe other panelists would like to share their views.
I would just add a little bit more. I think it's mainly a regulator's responsibility to try and structure markets so these things don't happen. It's a very hard thing to do abstractly, but inevitably feedback has potential to stabilize or to unstabilize. And you just flick the sign and you see either. I think really you have to create rules that actually sort of try and keep it in the stable part. It's an interaction. Individual players are often too small to actually impact on what really happens.
Thank you very much, both. Next question, would predictive analytics will either get stronger or more biased by reproducing inequities based on previous year's data? If the latter, what can we do to minimize biases?
I can quickly answer that. I think it's a very good question. There is a lot of discussion around that, especially in the context of about bias, especially in the context of retail finance. I think that the perspective that I take here is that what machine learning tools are bringing is actually that they allow us to identify the bias in the historical data that perhaps we were not always aware. So I see this as a positive, and now once we understand there is one, we can think how to mitigate this. And again, there are techniques out there to deal with that. One of them I can mention. This is something that is actually related to the work Michał and Terry are working, is on synthetic data generators, and that's the idea where even if you have a data set that might contain the bias, you might try to generate synthetically a data set that has as similar statistical properties as the original data set, but for example, do not include the bias that you don't want there. And this is a very helpful idea where you're trying to use machine learning to automate things, and you need to generate the data to train your models. But there are other ideas, and this will depend on the context.
Thank you. If no one wants to add anything else, then we can move on to some questions we received before this meeting. So what are the essential skill sets of the students who are interested in a career in quantitative finance? How do they develop those skill sets and stand out from the competition?
I probably can share my view. So because we actually I have done like interviews like in the past few years for students who are interested in finance industry or interested in the quantitative finance role. I think like first, actually I like this question like very much because I think the first thing is like I think everyone who is interested should get a good understanding of the machine learning theory. It is like very important if you want to, if you'd like to have a sustainable kind of growth in this area. This is a must. That's why I think our book is a good like a starting point. It is like a very well structured and also provide mathematical like a foundation basics like about the machine learning theory with the practice. The second thing is I know like many people are keen to learn say Python packages and machine learning tools. I think like this is definitely a good thing. In addition, if you have time, probably also try to improve the general kind of coding skill, because if you'd like to carry out a relatively like a big project, I think this is like super important. How you can structure, how to structure your code better, how to write a more effective code, no matter which language like you are using. The last thing I'd like to mention is I think maybe it's important to build up like the curiosity of like about like the machine learning in general, not restrict yourself just in quantitative finance like application. So you can read more from scientific paper, or you can get like information from some newsletter, read some more books. I think one should like broaden one's mind, have general like idea about what the machine learning can do, and then and also try to have solve some problems using machine learning, no matter whether it is financial data or not. Because I believe like a lot of knowledge, a lot of like problem solving skills, and also the knowledge about machine learning, it is kind of transferable between like areas. Yes, that's what I think. Yeah.
Thank you very much. We just, oh yeah.
Sorry, I just want to add that I agree with Xin. I think the transferable skill set is very important, like the problem solving skill, the communication skill, and programming skill. They are essential.
Thank you. We just received one more question. How do you see the field of rough paths evolve within the broader ML and quantitative finance communities in the next few years? Which areas of finance do you think it would be most disruptive for?
Terry, would you like to answer this question? Maybe I can share my thoughts on that. I think that the rough paths can bring the innovation to the machine learning of analyzing the sequential data, and the financial data stream analysis is a very challenging and interesting application field, as it has a low signal noise ratio, and for some user cases it has a limited data size, and the rough path theory can provide a potentially more parsimonious model to tackle those kind of application questions in the quantitative finance. And for myself, personally, I think the generative modeling on financial data is something very exciting. I'm working with this generative model with Lucas a little bit. I mean, generating the synthetic data set in finance could potentially make the financial data available to to have the better availability to other users, and it potentially can, I mean, we all know that in image recognition, once we have the public available data set, many machine learning researchers can compute it. But for finance, usually the data are confidential. But if we can produce the high quality financial data, fake financial data, and potentially it can trigger the more height of applying the ML to this field and bring more innovation, getting better results and so on. But of course, there are many other exciting directions as well.
Thank you. We can move to another question. So in fields such as image recognition, NLP, sharing data with other researchers have greatly promoted research in these fields. But in finance, sharing data seems difficult due to commercial license or so. What do you think researchers or institutions should do to promote data sharing and reproducible results?
Lucas, would you want to share your views on that?
Sure. Thanks. That's a good question. I think I'll partly answer that. Data is one of the biggest challenges that we face as we're trying to work within financial industry on projects about adoption of machine learning data science tools. And that initially gave us this kick to start looking into this idea of synthetic data generators, where which in principle give an opportunity to produce data sets that are usable, they have high utility for machine learning tasks, but at the same time they preserve privacy. This in itself is interesting research area, but I think it's we'll see more of it. There are other, of course, there are other ways of sharing data. There are various federated learning techniques that can be developed. The challenge, however, is that banks, depend on the context again. You know, I'm thinking at the moment about retail finance, for example. The banks, in principle, they do not own data. This is not their data. This is the customer's data. So they're really in a difficult position. So I'm a believer in synthetic data idea. I don't think there is a huge number of alternatives out there. Thanks.
Thank you. So one last question. Do you think that machine learning, artificial intelligence will eventually replace most of the jobs in finance?
Probably I can share my opinion. I think machine learning is good at solving specific problems, but of course it is pure rational and the lack of empathy, which is also important. Like right now, so like the automatic driving, it's everything, everyone knows it's okay, but somehow when you have some specific case, if you should just save yourself or save some the passengers, so it's the same thing in the. It would be also some similar things in finance. And when, for instance, for algorithm trading, then you should know how to treat some behavior finance. So how to consider the emotional and also how to choose just the rational signals. Yeah.
I just want to add that I think machine learning is still far from replacing most of the jobs. And on the other hand, personally, I think it actually, this kind of the technology, as Xing mentioned before, potentially can help people away from the repetitive work and focus on more imaginative and more exciting works. If one is working in the data science, I think one should know that to do the successful application using data science to the application, there is a lot of the manual work, and it still needs, crucially, the domain knowledge from the building the model, choose the best model, validation, and so on. So it's not the entirely automated process. I couldn't see in the near future the machine learning can replace the most of the jobs in quantitative finance. But in the long term, I think the best way is that we can use it as the useful tools to free ourselves to do more exciting work. Yeah.
Thank you very much. As mentioned in the chat box, the book will be on a special 20% discount till end of June. Please get your copy from our online bookshop. So thank you all for attending, and thank you, Professor Lyons, Dr. Spruch, Dr. Ni, Dr. Dong, Dr. Zhen, and Mr. Yu for taking the time to share your thoughts and insights. Thank you very much.
Thank you.
Bye.